Laboratory evaluation of its test on asphalt modified with various ranges of Crumb rubber. This article is written by two authors. First author Asma Abdul Majd Mamasani. Second author Barhamdul Nariman. Contribution and originality of the study is that, this study contributes in the existing literature, to investigate the binding medium between concrete asphalt with Crumb rubber. This study uses new methodology which is called wet process, mixing Crumb rubber with asphalt prior to the aggregate. This study originates new formula to improve asphalt and asphalt concrete. This study is one of very few studies which have investigated tensile strength ratio, TSR, by using indirect tensile strength test, and elastic recovery for conventional mixture. The rubber which is generated from scrap tires, identified by crumb or powdered rubber. Day after day, discarded or scrap tires create huge environmental problems. As long as the scrap tires are regarded as a non-decade material, those disrupt the clean environment. Using this rubber in pavement and asphalt has become a great interest and proposal for researchers for overcome this issue in recent years. Researchers and engineers discovered another way to improve asphalt concrete, by adding Crumb rubber, CR, into asphalt concrete. This is done by two methods. First method, rubber placed in bitumen and completely or partially reacted with bitumen, this will become binder modifier, wet process. Second method, replacing this rubber with fine aggregates which are not dissolved completely with bitumen, dry process. In this study, Crumb rubber is added into mixture initially by substituting rubber with amount of fine aggregate. Thereafter laboratory tests, penetration, ductility, softening point, elastic recovery and moisture susceptibility test were conducted. These tests were performed, investigated and compared to evaluate the effect of indirect tensile strength, ITS, on asphalt concrete modified with several ranges of Crumb rubber. It has been shown that 0% is control sample, while 2, 4, 6, 8 and 10 are percent of rubber by the total weight of aggregate. One of the critical issues in asphalt pavement is moisture damage. The existence of moisture play a great role in reducing the stiffness of the asphalt mix as well as makes the chance for stripping of the asphalt from the aggregate. This study evaluates the strength loss by comparing two methods of its test, which are conditioned, tested in saturated state, and unconditioned, tested in dry state, samples. Marshall mix method was applied for preparation of total 24 samples for both states of its. The results show that for conditioned samples 6% of CR gives the highest value of tensile strength, 892 kPa, while in unconditioned samples, 10% of CR gives even higher value of strength, compared to conditioned and control sample, 933 kPa. According to AASHTO T283-14, the tensile strength ratio, TSR, result of all samples are within the standards, using the minimum value of 80%. For asphalt modified fault width, 2, 4, 6, 8 and 10% of CR, the TSR values are 95.3, 97.7, 97.4, 93.6 and 90.9% respectively. Moreover, the results are discussed in detail in this study. As summary, the optimal dose of CR is 4%, which gives better performance for penetration, softening point, elastic recovery and tensile strength ratio. Thanks for watching this video of International Journal of Natural Sciences Research Volume 6 Issue Number 1.